Hi students, welcome to Earth and Environmental Science and Module 6 on hazards. This is video number 7. We're going to be focusing on disasters. The learning intention for this particular video is for us to investigate the point at which a geological hazard becomes a disaster. In order for us to do that, we need to make sure that we understand the term disaster and be able to contrast those terms hazard and disaster, and then more to have not just a list, but to be able to evaluate some of these critical factors that determine whether a geological hazard actually becomes a disaster. So the first thing that we need to do is to define these two terms. So at the moment we've been focusing on hazards, and hazards are possible or potential risks. So they can turn into disasters, certainly, but they can also turn into something that's not having too much of an impact at all. And we've looked at some examples so far of particularly tectonic activity, seismic activity, and volcanic activity, and how these can have an impact on the geological landscape, the topography, but also on the inhabitants, on people and their possessions, their buildings, their infrastructure, once these sorts of types of hazards actually come about. So whether we have an earthquake, whether we have a volcanic eruption, and what are some of the potentials for damage in each of those situations. So whilst we've had a little bit of a look at both seismic, which is earthquake, and volcanic, which are different types of eruptions, at the moment we haven't really sort of crossed that boundary into where do hazards actually become disasters. And of course, there's some discussion about this, but mainly we tend to be a little bit anthropocentric when we talk about these sorts of things. So we really think about how they affect us. So the impact on humans is often the most significant factor in determining whether a hazard becomes a disaster. It's how many people, how much property, how much infrastructure maybe is damaged in a way that makes it very difficult for it to bounce back. So it's not just, say, a death rate. It's not just the amount of ash that might be covering a huge area. It's how long it might take for those communities to rebuild, to come back to where they were prior to the geological event. So this is what we're looking at when we're trying to analyse where a hazard becomes a disaster. That said, hopefully that last slide gave you a little bit of an idea of the sorts of factors that you want to consider when you're trying to determine whether or not something is moving from the area of hazard into the area of disaster. We said one of the reasons why, first of all, may have to do with humans in terms of the population density. Obviously, if there's a volcanic eruption or an earthquake, particularly a large earthquake that happens in a heavily populated area, the population that's going to be affected by that is significantly higher than if it's, say, an earthquake that happens on an island that's a reasonable distance from any other inhabited islands. It may be a disastrous eruption, but it may not be a disaster in the fact that it doesn't impact on humans very much, if at all. The built environment is also important. We know that, for example, there's areas around San Andreas which have, and not just in the United States, but plenty of other places too, where there are very specific codes, and some of this is going to come back to management and government policy that often are interchangeable between these two, which is the sort of policies that have been created with an eye to the potential disasters that could happen. So the requirement for buildings to be earthquake resistant in areas like San Andreas, up to a reasonable point, of course. If the earthquake that hits is big enough, then it can still cause significant damage. But part of the idea is that there's a resistance up to a certain value. And of course, the more significant the event is, the less likely it is to happen. So these huge events don't happen as frequently as more minor events. And if the built environment, if the policies that are in place ensure that the buildings, the infrastructure conforms to certain requirements, then it may well be that it can resist even some reasonable geological events without actually suffering significant damage or loss. We're going to talk a little bit later in this topic about early warning systems, and early warning systems is really one of the holy grails of this type of study. the earlier we can identify what sort of things are going to happen and where they're going to happen and potentially how big they are going to be, the better off we are to be able to not just warn people who might be affected, but actually to move them if we need to from one place to another. This, of course, is still a science that is not as accurate as we'd like, not as precise as we would like it to be, and therefore there's a whole lot of research that's going into the different types of geological hazards and how we might be able to improve our methods of detection and prediction and potential impact. The nature of the hazard itself is something that probably goes without saying, but we won't leave things without saying because we want to include all of these key factors in our lists. And so whether it's an earthquake, the size of the earthquake, the magnitude, whether it's a volcanic eruption, and that can be impacted by the type and the composition of the magma, as we've looked at previously, as to whether or not it's a quiet kind of effusive volcanic eruption, or whether it's an explosive one with lots of ash, lots of pyroclastic material, and quite significant damage to the volcano, the side of the volcano itself, and any other land around about that particular eruption. So these are some of the factors that you want to consider when you're trying to analyze whether or not a disaster or a hazard should be regarded as a disaster. Going through this list gives you a nice little checklist of things that you can work through in order to consider those factors. And so here's a little activity for us to have a look at in class. The Kamchatka Peninsula in Siberia, which is a region that's right up in the Russian Far East, bordering on the Pacific Ocean. So think China, Japan, keep going further north. That sort of region is what we're looking at for this part of Russia, this part of Siberia. Around about 160 volcanoes in the region, 29-ish of which are still active. This is one of the regions of the world that is most active in terms of volcanic activity, certainly in terms of its density. The location in terms of how far north it is contributes to the fact that it can get extremely cold in these areas. So it really is a land of ice and fire. But despite the high volcanic concentration, we don't tend to talk about disasters associated with this particular region, Kamchatka in Siberia. Why do you think that is? We might have a little bit of a look and see if we can use our little list of key factors to work through why we might not regard this particular area, though it can be high in potential hazards, as a disaster zone. But we'll do that in class. Thanks for watching.